All right, this is lesson 2.1 in the book. We are going to add integers, decimals, and fractions. Now, this is the homework that goes with it. I am going to tell you guys right now that some of this is definitely review. Adding integers, okay? Adding numbers with the same sign. To add two numbers with the same sign, you add their absolute values. The sum has the same sign as the add-ins. If they are different signs, you subtract and take the sign of the larger. I like to say this. When you are adding integers, think money. And if I'm writing this down, you should be writing this down. Think money. So, write down these four problems. 4 plus 2, negative 4 plus negative 2. Negative 4 plus 2, and 4 plus negative 2. These are all addition problems. Tonight, it is only addition. We are not dealing with subtraction. We are only dealing with addition. Think money. If I have $4 and I have $2, what do I have? Everybody, $6. How do you think money here? You owe me 4 and you owe me 2. So what do you have? You owe me 6. This one, you owe me 4, but you have 2. What is that answer going to be? You still owe me 2. And this one, you have 4, but you owe me 2. Aren't you going to still have 2? Now, these first two, the signs are the same. So, if the signs are the same, add and keep the sign. You add the numbers, keep the sign. If they are different, what do you do to the two numbers if the signs are different? Aaron, you subtract and take the sign of what? Yep, take the sign of the larger. You add and take the sign of the larger. So, things to remember. When adding or subtracting decimals, line up the decimal points. When adding or subtracting fractions, you need to what? Find common denominators. And absolute value, which we've already been talking about. Absolute value is the distance a number is from 0 on the number line. And it's going to always be positive. Now, why am I pointing that out? Because the lesson is not just adding and subtracting integers. We're going to do decimals and fractions, and we're going to do a couple examples after we do this. So, evaluate each expression. For A is negative 2, B is 3, and C is negative 4. So I am going to substitute. But when they have negatives in front of variables, sometimes it screws kids up. This is negative A. But what is A? Negative 2. So minus negative 2. Plus 2 plus C is negative 4. Again, what happens to minus a negative? Everybody.
Add the opposite.
Add the opposite. So I'm going to have, what's 2 plus 2? 4 plus negative 4 is, that ends up being 0. 2. A is negative 2 plus negative B. Negative B is 3. What is negative 2 plus negative 3, Thomas? And now look at this one. Minus the absolute value of A, which is negative 2. Now, do I go minus a negative becomes add the opposite, or plus a positive? No, because this is absolute value. Bring down this negative. What is the absolute value of negative 2? Everybody? 2. So this is going to be negative 2. That negative is getting carried along. All right, let's look at this one. Without calculating, which is greater? The sum of negative 227 and 319, or the sum of negative, or of 227 and negative 319. Which one's going to be greater? Paige. Why? What kind of number is it going to be? Greater. This is positive. This one is going to be, what's the answer to this going to be? Negative, right? Let's replace it. This one's going to be negative. This one's going to be positive, so we know that this one is bigger. It doesn't matter what the answer is. It matters that it's bigger. All right. Explain what is wrong with the reasoning of this statement. Since 20 degrees is the opposite of negative 20, then 20 degrees Fahrenheit must be very hot because negative 20 degrees Fahrenheit is very cold. I think that's kind of a silly problem. That's not how temperature works, right? Just because they're opposite doesn't mean that since one is very cold, the other has to be very hot. That's not how temperatures work. You're right, negative 20 degrees Fahrenheit is freezing, cold. I mean, below freezing, way below freezing. 20 degrees Fahrenheit is still what? Below. It's still below freezing, right? Because isn't freezing 32 degrees? Freezing is 32 degrees Fahrenheit. So they're both cold. They are both cold. Very cold. Very cold. But they are opposites. But just because they're opposites on the number line doesn't mean that they're opposites in the scenario. All right, now, I want you, I'm not doing subtracting today. I want you on another piece of paper to write down some of these examples. This is where advanced comes in. If I gave you this problem, negative 5.2 plus 8.479. Negative 5.2 plus 8.479. What kind of problem is it? It's adding. Are the signs the same or different? They are different. So when they are different, what do you do to the two numbers? Chloe? You subtract them and keep the sign of the larger. So before I've done any math, I have done what I like to call sign analysis. And that's what we just did. We said, okay, this is an adding problem. The signs are different, which means I'm going to subtract and take the sign larger. What kind of answer am I going to have up here? I'm going to have a positive answer. Now, these are decimals. So when I am subtracting decimals, what do I need to remember to do? Line them up, and which number needs to go on top? No, not the positive number, no. The larger number. What is larger? 8 or 5? 8. When you subtract, doesn't the larger number have to go on top? It has nothing to do with positive or negative. The positive and the negative tells us that we're going to have to subtract these. the bigger number has to go on top when I'm subtracting. So 8.479 minus 5.2. I'm going to put 2 zeros in. Do I really need to put those zeros? No, because I don't need to borrow in this case. So I'm going to subtract 9, 7, 2. I made this an easy one. 3.279 means my answer is going to be positive or negative. Positive. It is going to be positive because my bigger number was positive. Okay, now, this is where things start to get tricky. 4 2/5 plus negative 10. 4 2/5 plus negative 10. Let's do sign analysis. What kind of problem is this? It's adding. Are the signs the same or different? They are different. So if they are different, what math am I going to do? Subtract and take the sign the larger. So is my answer going to be positive or negative? Everybody. We know that our answer is going to be negative. Please keep that in mind because there's a lot of work that goes into these and we need to not lose track of the fact that our answer is going to be negative. Now, I'm going to subtract these numbers. Which one has to go on top? The what? Everybody. Larger number. Which is bigger, 10 or 4? 10. So I'm going to do 10 minus 4 2/5. Now, if you guys are like my other classes, you are not going to be good at this. Can I do nothing minus 2/5? So what do I need to do, Chloe? I need to borrow. So I'm going to make the 10 into a 9. And how am I going to write the 1, Logan? Thank you. 5/5. Do you guys agree with Logan that 10 is the same as 9 and 5/5? Because 5/5 is 1 plus 9 is 10. Now I can subtract. 5/5 minus 2/5 is 3/5. 9 minus 4 is 5. And let's not forget that the answer is going to be negative. Okay, let's try this one. Negative 2 3/4 plus negative 1.75. So I have two choices. First of all, what kind of problem is it? It's adding. Are the signs the same or different? They're the same. So I'm going to do what to the two numbers? Add and keep the sign. So what is my answer going to be? What kind of number? Negative. Now, what do you notice about this problem? Can you add a fraction to a decimal? No. So you either need to make these both decimals or both fractions. What do you choose? What do you choose, Chloe? Okay, so Chloe is going to change this to negative 1 and what is 0.75 as a fraction? It's 3/4. Or you could write 75 over 100, right? 75 hundredths is 75 hundredths. I'm going to just go to 3/4. Now, I don't really need to stop these stuff, and will you stop doing that, please? I'm going to add these. I'm going to get negative 3 6/4. Oh my. Is that the answer that I want? No. Because this is an improper fraction. How many times does 4 go into